Recording. Okay, so we're going to go ahead and finish, well, pick up where we left off on the review guide. I don't know how close we'll get to finishing it, but we'll see. We have time. All right, so let's go ahead. So yesterday we covered domain and range, finding slope, x and y intercepts. We understand that we can find those through using the slope intercept equation or the slope point form. All right, so now we're moving on into modeling linear data. So this is the section where we learned about our scatter plots. So in this case, we are given, hold on, let me stop my recording. Okay, so they have given us a table of data. And they have asked us to plot it. So once you plot the points, you then create a line. What do we call that line? We can't make a line out of a scatter plot because they are scattered in a non-linear fashion. But we make a particular line that represents, we make a trend line. Yes, and the trend line falls as close as possible between the points that we graph from the scatter plot. So how do I turn this table into points? Okay, right. So each of these x and y's are just an ordered pair. This is -1, -5. This is 1, -2, 3, and 1, 5, and 2. So we plot those. -1 means I go what direction? Left 1. And after I go left 1, what direction do I go? Down 5. 1, 2, 3, 4, 5. So I've got my first ordered pairs right here. Ish. Extremely messy. All right. And then 1, -2. The 1 tells me I go what direction? Right. -2 says down. Right here. 3. I go 3, right. I go 1, up. So right here, we are pretty close to a straight line so far. 1, 2, 3, 1, 2. Yeah, they are pretty close. I might have made these a little too close. What about 5 and 2? So I go 5, 1, 2, 3, 4, 5, and then I go 2, up, and I've got this guy. All right, this one's a little more off my line. But when I draw my trend line, it's going to be something like that. Maybe a little more, I don't know. This is where I fail. I fail pretty miserably. But either way, we know that when we look at the line and when we look at the points, we need to look at the correlation of these two. So when the dots are really close to the line, would we call that a strong correlation or a weak correlation? Strong, right? The closer to the trend line that the majority of the points are on, okay, then the stronger the correlation between your trend line, because your trend line represents the linear equation that you use to estimate or predict data outside of or inside of your data points. And so it makes, if it's a strong correlation, then that means that that linear equation for it is more accurate. It's going to give you a better prediction about future data or, you know, random data in between. So this is a strong correlation. Now, is it positive or negative correlation? Positive. What tells you that it's a positive correlation? What was that? It's going uphill. So this is a strong positive correlation. So if you go to the section in your textbook, I want to say maybe 2.3, 2.4, I think it's 2.3. If you see a scatter plot that's like this, and you have to put the line through here, then we have a very weak correlation. And then, so let me just make sure I'm clear on what that's my X and Y. And then if you have it like this, then you have a very weak negative correlation. So that means that your Y is decreasing, even though your X is increasing when it's going downhill. When it's going uphill, they're either increasing together or decreasing together, but they're both going in the same direction. All right, so in this case, we have a strong positive correlation. Strong tells us that all the points are close to the line, and positive is because the line is going uphill. Okay, it's essentially all you'll need to know for the most part about scatter plots. All right, so now we're getting into graphing. So what do we call this that we're looking at for A? Y'all remember what this is called? I'm trying to remember. Piecewise, yes, thank you. So piecewise means you have multiple graphs on the same Cartesian plane. And so this is 2.5, where we get into special functions. So what we have to do is we have to graph both of them. So you can rewrite this for every different f of x that you have. So we could say that this is the same as f of x is equal to 3 if x is less than 1. And the other one, so I'll label that number 1. Number 2 is f of x equals 2x minus 5 if x is greater than or equal to 1. All right, so f of x stands for what? Y. So this is the same thing as y equals 3 if x is less than 1. So the y equals 3 means we have what kind of line? We have a straight horizontal line. But where is that line going to start? Which x value does it start at? Right, so here's your x values. So if y equals 3, no matter what, we don't have a straight line at y equals 3 all the way across. It has to be less than 1. So we start at it's 0. What else is it? Right. So if it goes forever, how do we draw that? Where do we start our line? What do you think, Matthew? Where do we start the line? At 1. But what kind of circle do we put at 1? Open, right? Because 1 does not count. So our line starts at 3. 1, 2, 3. There we go. So this is 1, 3, right? X equals 1. And at every point, y equals 3. Now, what direction do I go in? Left or right? Left, because left is all of the values of x that are less than 1. Do I stop? No. So the only place you stop is at the very end of the graph. That's where you put your arrow. All right, so the open circle is because it's less than but not equal to. The straight line is because y equals 3. There's no slope. There's no change. It is 3 no matter what x is. And it goes all the way to the end of the graph because we're not given a limit for x. We're not given a beginning and an end. We are only given a beginning. It starts at 1 and it goes forever and ever, amen, less than 1. That's it. All right, so that one's graphed. So let's look at number 2. So if we graph f of x is equal to 2x minus 5, f of x means what? Y. So we're just oops, here we go. I know, Word is awesome. Every time I try to rest my hand so that my handwriting is legible, it flips out. All right, so f of x just means we're calculating our y. So y equals 2x minus 5. See, this is what I mean, not legible. And so we can solve for y, but we've got to pick some x's. What x should I pick first? And make a table. Yeah, we start here, right? X is greater than or equal to 1. So I would definitely pick what our y is going to be when we start our graph. So we're going to start at positive 1. What's another value? 2. Maybe one more? Yeah, let's go. You just need 2, but I like to have 3 because that gives me an idea of my slope so that I'm actually, the angle of that line is going in the right direction. All right, so if x, excuse me, let's do it this way. If x equals 1, so this is f of 1 equals 2 times 1 minus 5. So you just plug in 1 for every x. In this case, there's only 1. And so where x is 1, y is 2 minus 5, which is negative 3. Okay, function of x at 2, excuse me, means this is 2 times 2 minus 5. So that's 4 minus 5. So it is negative 1. So we've got a positive slope here. Every time x changes to the right, y goes up. All right, so I'm going to just one last one. F of x at 3 is equal to 2 times 3 minus 5, which is 6 minus 5, which is 1. Okay? So once I have my table, I now have 3 ordered pairs for this second graph that I can plot. So I have, I'm just going to draw a little arrow here. That's not an arrow, but whatever. There we go. So this is my ordered pairs: 1, negative 3, 2, negative 1, and 3, 1. All right. So 1, negative 3. The 1 tells me I go which direction? Right. And the negative 3 says I go down. So right 1, down 3. It's right here. 2, negative 1. So I go right 2. Negative 1 means I go down 1. And 3, go over 1 more and then up 1. So this tells me I have a slope of every time x changes once, y changes twice. So my slope is 2. Now the question is, how do I draw this graph? What do I have to look at to know how this graph is drawn? The what? The x is greater than or equal to 1? Yes. So that means this line starts at what point? It starts at 1. So your x, left or right, you cannot go any farther than 1. All right. Is that point at 1, is it filled in? Is it solid or is it an open circle? Open circle. Why? Because of the equal to. All right, so I can leave it like I've drawn it as one at 1 point, a solid point. And then where does it go? Obviously, if we're starting at negative 1, what did I do here? If we start positive 1, it goes up and to the right. Does it end? No. So you're going to draw a sharp little line all the way to the end of the graph with an arrow. showing that it will go on forever. So that shows my starting point. All right, any questions? Does this make sense? Okay. I hope so. All right, so our next one is we have a family of functions here. We have a parent function and then we have our translation function. I'll get it later. All right, so the second one, we use our parent function and our translation function to figure out how we're going to graph this. So really, all you need to calculate is what? The specific point on this graph. What do you have? Sort of, it's the midpoint. Yes, it's the vertex. Remember, the vertex happens when you have like the angle of a triangle. When two lines intersect, they intersect at a vertex. So we're finding, which is also, you are correct, the midpoint, because that's what happens at the y-intercept, or well, it's what happens like at the middle of the graph, but then it goes on to infinity. All right, so our parent function is absolute value. And what do we know about absolute value graphs? What do they look like? V's, always. So if you have absolute value in your function, you should never have a straight line, ever, ever. Because at some point, y is positive. All right, so our parent function is absolute value. Do y'all remember the translation function? I don't have that. So yeah, it's y equals the absolute value of x minus h, close absolute value, plus k. So what you want to do is you want to write your equation, write your formula, excuse me, with the signs. Just leave blanks where you would put your h and your k. So in this case, we have x plus 2 inside our absolute value. So how do we write x plus 2, but with a subtraction? X minus negative 2. I'm going to give myself a little bit more room. So we have to keep everything exactly the same as our translation formula function, but it has to mean the same thing as our original function that we're trying to graph here. So we have to write x plus the number, plus 2, but using a subtraction. And we know that because subtraction is just adding the opposite, then we flip the sign of that 2 to negative 2. Because does x minus negative 2 equal x plus 2? Yes, yes, right. Double negatives are always positives. All right, so what about the negative 4? So negative 4 means, so that should be plus. How do we write plus k with a negative 4? Plus negative 4. Does that mean minus 4? Right. So you can see how now our translation function is using the form of our function, but we are meaning the same thing that our original function tells us. Absolute value of x plus 2 minus 4. So that way you get the signs right of your vertex. That's why this is so important. So if our vertex, so what's our vertex? Our vertex is h and k. H is the x and k is the y. So it's negative 2, negative 4. That was an interesting return. And that's very important because ordered pair negative 2, negative 4 is very different place on your graph than 2 and 4. And when you use your origin test to figure out if this were an inequality, which is not an inequality, but if it were, you would be shading the wrong side if you put it in the wrong place. Okay, so if we go ahead and graph this, -2 tells me that from the origin, I go in what direction? Left 2. And -4 says I go down 4. So 1, 2, and then 1, 2, 3, 4. So my vertex is right here. And the slope of, at least, don't do that. The slope of an absolute value is always 1, at least where we are right now. So it's just going to go like, it's just a 1-to-1. Goes through all the, which that doesn't, but I started off that way. See, I cannot even, there it is, there it is, there it is. Something like that. That's close. And that's it. So as long as you have your translation function and then you put in the values correctly, you're good. It's not really a lot of math. It's just don't make negatives magically disappear. All right. Let's go ahead and do another one. Now we're moving on into inequalities. So this one is already in standard form. Do y'all want to use the ABC to determine slope and y-intercept, or do you want to convert it into slope-intercept? Just use our ABC? Okay. You can do that. So we'll label our A, B, and C, and then slope is negative A over B. Still have to kind of remind myself of this. X-intercept is C over A. Y-intercept is C over B. I think that's right. Okay, so what is A? 2. What is B? -4. Very good. And what is C? 9. Okay, so my slope is negative A over B, which is a -4. And so what does that simplify to? 1/2. Who was that? Good job. Sorry, can y'all see that? I can't, but I'm like farthest back. Right, so this is a -2 over -4. Because it's a negative, we're looking at a positive, and then we simplify 2/4 to 1/2. All right, what about our x-intercept? Yeah, it's 9. Yeah, this is no fun. So 9 over 2, 0. And y-intercept is C, 9 over -4. So -9/4. So for x and y-intercept, like I've said before, I'm totally okay in that case, maybe turning it into mixed numbers, because 2 goes into 9 4 times, and then there's 1 left over. So you know you're sitting somewhere between the 4 and 5 of your x. This one, wait, did I? Oh, right, 9 over 2 and 9 over 9. Okay, so negative, what, 2 and 1/4? Thank you. Okay, so be careful, because -2 and 1/4. Yeah, you should be fine. Right, is farther. It's like just a smidge past -2. All right, so when we graph this, you already have your 2 points. You have your point on the x-intercept and your point on the y-intercept. So graphing it, the x-intercept, we would go 1, 2, 3, 4, but then about a half more. So we've got this one right here. And then the y-intercept is -1, 2, and then just a little bit past it. So maybe somewhere about right here. Now, oh, stop it. I'm going to move that. That ringing is interesting. All right. So when I draw my line, what do I need to check? After that, so funny. I just said, I wonder what that noise is. And then you answered it. Thank you. All right. I'm sure they'd rather than this. What kind of, oh, it's already gone. What kind of line do we draw here? It is a straight line, but it's a dashed line. Yes. Why is it a dashed line? Because we have an inequality. And so our solution is not included in our answer. It's just everything less than our solution. So the boundary line must be dashed because it's not included. So somewhere like this, and it does go forever in a straight line, somewhat straight. I just can't. I can't draw a straight line, much less dashed. All right, are we done? Are we done? No. We have to shade in our solution set. Exactly. So what do we do to do that? The origin test. So the origin test means that we plug in x is 0, y is 0 into our original equation. Is it? So the origin test is true? And you shouldn't necessarily have to like put it in. You know that 0 minus 0, anything times 0 is 0. 0 minus 0 is 0. Is 0 less than 9? Every time. So that means whatever half plane that includes the origin is your solution set. So we know that 0 is less than 9. At least put that if you want to. So the origin makes this a true statement. So that means that the half plane including the origin is our answer. There we go. I'm glad that still clicks. Okay, my page won't move. Come on. Let me try it with an eraser. Oh no, we're just gonna be like this. Okay. All right, so now distance and midpoint. This is easy when you don't forget to keep the square root as part of your solution until you get to the very end. I appreciate your willingness to confess in front of everyone. I will make you feel better by saying you were not the only one. So don't make things magically disappear. We are not wizards in here. It is not real. And it will screw you over. Okay, so what's the distance formula? Right. So it is the square root of the difference in x squared plus the difference in y squared. And then the midpoint? This is the average. Yeah, x1 plus x2. Could you do x2 plus x1? Yes. This is not going to fit. The important thing here is to make sure that you only add your x values and then half them, and then only add your y values and half them. Don't use the x and y and add those together anyway. Yeah, just double check yourself, double check your numbers. Okay, so distance, I am going to label. So this is x1, y1, x2, y2. I'm gonna do what I always do and make them as like a list. So x1 is 2, y1 is -1, x2 is -2, y2 is 7. Oh, lovely. Anything involving 7 is rarely a perfect square. All right, so we'll see what happens. Okay, D, so we just plug and chug. D equals x2, which is -2. This is the important part. Make sure if you're subtracting a negative, either change it to addition or just put both negatives on there. In this case, I don't have to. -2 minus 2 squared plus y2 is -2. -2 minus, okay, y1 is negative. So this is -2 minus -1 squared. So you can, oh, you're right, it is. See, again, here we go. Wait, I did the wrong one. Hold on. Okay, so -2 minus 2, and then 7 minus -1. There we go. So now fixed it. Okay. Can we also just go ahead and change this to 7 plus 1? Okay, thanks. And we know why it's plus. Right. Okay. All right. So then we just simplify. Now at this point, if you want to simplify inside your parentheses, probably shouldn't even show that to you, but because anything times itself, even if it's negative, it's going to be positive because that's a negative times a negative. All right. So make sure you keep your parentheses. So negative, what's -2 minus 2? Hello? Sure. No problem. No problem. Yep. Okay. Okay. So either keep your parentheses, or no matter if it's negative or positive, just turn it into a positive. Because this is -4 times -4, which is what? Positive 16. And 8 times 8? 64. And what's 16 plus 64? Oop, that was really long. Square root of 80. All right. 2, 4. You know what? I'm just going to leave it there. There. You could, the only thing that you could do is you could change, you can see that this is 80 is 4 times 20. And 4 is a perfect square. So when you multiply them, that's when, oh gosh, I'm running into my room elsewhere, but that becomes 2 square root of 20. I probably wouldn't count off much if you left it as square root of 80. Just, if I can just get you to keep the square root, I'll be happy. What time is it? Okay, let's finish this one and then we'll call it a day. Midpoint is x1, which is 2, plus x2, which is -2, and over 2. And then y1 is -1, plus y2, which is 7, over 2. All right, what's 2 plus -2? And -1 plus 7? Good catch. Is 6. All right, so what is 0 divided by? What's anything divided into 0? 0. And 6 over 2? 3. So what's our midpoint? It is our, so our midpoint is our y-intercept because x is 0. Yep. Let's go. Yeah, literally. Oh, it's 13. Oh, yeah. So in one, I gave you kind of a funky distance. The other one has kind of a funky midpoint. It's 4 times 20. And what's the square root of 4? 2. Well, 8's not a perfect square. Like you have to find a perfect square that goes into that number. So like I could do 8 times 10, but neither 8 nor 10 are a perfect square. So I still can simplify it. But 4 is a perfect square. And I can simplify square root of 4 to 8. And so it becomes square root of 4 is 2. So it becomes 2 square root of 20. But that's the only perfect square because 9 doesn't go into it. 16 go into 80? No. Yeah. And 25 definitely doesn't. And then nothing bigger than that's going to. So anyway. Okay, we're done. It's not my video.